Hello everyone, welcome to this section. And by the header of that section, you have already understood that I'm going to talk about Istio. So, one thing before I proceed is that Istio is not part of Kubernetes, it is separate. So, if you go to Kubernetes documentation, you'll never find Istio there. So, it's a different technology or software altogether which works alongside with Kubernetes. And there are huge use cases which use Istio. Maybe more than 90% of the time, if you work on a production cluster or anywhere with Kubernetes, you'll come across Istio more often than not. But let me put a disclaimer here. This is not a detailed course on Istio. I'll not go into the details. So I'll just tell you the things which are needed, which I think that are needed. And it is no way would be a deep dive on Istio, unlike Kubernetes. I'm not going to cover Istio in detail in future also because this is a complete different technology. The reason I have included Istio is because it is needed, as I said, more often than not, we'll be working with Istio. All the cloud service providers use Istio, which is a service mesh technology. So that's why it's better to cover this and give you a little bit of description what Istio is. We will also do hands-on on Istio and various things that are there that can be done using Istio. So let's proceed. The first thing that I want to discuss is service mesh. So what is a service mesh and what does it do? We have not come across this term ever in this course, and this is the first time I'm discussing this. But you know what and how you deploy application using all the Kubernetes objects. So I've not created any application yet, which anyway I'll do at the end of the course. We'll create a case study and an application which will be hosted on Kubernetes, and I will try to cover whatever I have covered in that case study. But in production, you'll find this concept or you'll find this terminology a lot, service mesh. So let's see what that is. The first thing is that we have this Kubernetes cluster. And let's say we have deployed one application in this Kubernetes cluster. Let's say that's an online retail application. So there will be multiple components of that application, and all those components have been hosted on this Kubernetes cluster, which I'm showing you. So we have this front-end portal, which takes care of the front-end part. Then we have back-end processing and back-end shipping. And then we have order processing, inventory analysis, and some external database connection. It's a very small and very simple application. So this is how all the application components have been hosted on this Kubernetes cluster. You can think of these as pods or deployments or services, but eventually all of them will boil down to an application component, and that's what I'm trying to show you here. So these are all application components, either using pods or deployments or services. So typically I'll be using deployments and services to deploy these application components. Now what I want to discuss here is that these pods or these application components will talk to each other. So let's say the front end portal application needs to talk to backend processing, backend shipping, inventory analysis, and order processing, because when any user places an order, that user can come and check the order status also. Now, while placing the order, the user or the application, the front end application, has to check the inventory based on which the order would be placed. Then backend processing, backend shipping once you place the order. So this is how the connectivity is. So front end portal is talking to backend shipping. Then it is talking to order processing. Backend processing is talking to front end portal, and front end portal is also talking to inventory analysis. Similarly, let's say backend processing, backend shipping, order processing, etc. talk to other components like this, and backend shipping and order processing talks to the external database connection. So all these application components are called as microservices or web services or services in short. What I'm trying to show you here is see the connectivity, see the communication between these services. It's a very small application with only 6 components. Can you imagine an application having hundreds of components? These communications can become really big and really complex. So the service to service communication is something that we have to take care of from the application. Kubernetes does not give us any visibility or anything as such to manage these communication. So if front end portal has to talk to, let's say, the backend shipping or backend processing, the application of the front end portal has to handle that. So application meaning if you write an application using Python or Java or anything, we have to take care of the communication between these backend shipping and backend processing from front end portal using either cluster IP or node IP or a load balancer. Services are implemented using load balancer and cloud service provider. So it can be anything. So now similarly, it has to be handled in all the applications. So you not only have to take care of the application, you also have to bother about the service to service communication across those application components, which can become really complicated once your application becomes big. Not only that, major problem is that Kubernetes does not have anything out of the box which can give us the visibility of this application to application communication or service to service communication. So if something goes wrong, how do we troubleshoot? It becomes really difficult if we use only Kubernetes. Now, there are other things also, like what about routing and discovery? Let's say you have one more service added or one more feature added. The moment that is added, you have to make sure that all the other services or all the other application components can reach out to that particular application, to that new application component or new service. Those things have to be handled using the application also. You can use load balancer for routing and service discovery, or basically service discovery. But what happens is that as your number of components grow, so will your number of load balancers. So let's say you have 50 different components, you'll have to create 50 load balancers. The more application components you add, the more load balancers you'll need. So as you can see at the hindsight, this is not a very nice model or nice architecture to use load balancer to provide service discovery and service to service communication. Now, there are some other complications also, like what about the security of the services? Configuring routing rules, firewall rules, etc. How do you monitor each and every application component? Like which service is talking to which other service? What about the encryption of traffic between the services? Also authentication, etc. So that's where service mesh comes into picture, and it helps in a great deal because just using Kubernetes, the problems that I discussed in the previous slide cannot be solved. So what does service mesh do actually? We have the same application on a Kubernetes cluster: front end, back end, shipping, back end processing, order processing, inventory analysis, and external database connection. So now all the intricacies that I was talking about, except the application code itself, can be taken out of the code and be placed separately, just like this. So all the configurations of routing, service discovery, firewall rules, the SSL setup between those applications can be handled separately out of the application. So whenever you have to make any changes in the configuration, your applications will be untouched. You'll never have to manage the service mesh or the service to service communication within the application itself. So all these combined together is called a service mesh, which handles the service to service communication along with other stuff. So this is what a service mesh is. Now it changes the communication of the pods drastically, because what happens is that, let's say the front end portal wants to talk to the backend shipping service, you'll go to the service mesh, and service mesh behind the scenes will take the traffic and put it or send it wherever it is supposed to be. Now the direct service to service communication is out of the way, as you do not have direct service to service communication. So applications are devoid of the configuration and communication along with other stuff. So the entire communication logic is handled by the service mesh. You can think of service mesh as a software which sits along with the pod or along with the application component. It is better to picturize the service mesh as such, as if it is a centralized thing, but it is actually not. It is implemented in this way: it is taken out of the applications and placed separately. So as they have communication between them, I'm showing you service mesh as a single logical component. Now what about monitoring? So We talked about service to service communication logic. Now there's this monitoring part also. As you can see, all the communication goes through service mesh. Every request from one service to another service goes via the service mesh. We can track those requests in the service mesh itself and send it to third party tools like Prometheus, Grafana, Splunk, etc. to handle the monitoring and also to give you an overview how the mesh or how the application components are connected to each other visually. Not only that, the security of or the TLS communication will also be handled by service mesh, and that is outside of the purview of the application. Now, Istio provides one type of service mesh implementation. So Istio is actually a service mesh with gives us all these functionalities along with a few more. So before going into Istio, I'll have to talk about Sidecar and Proxy. So what is this Sidecar and Proxy? Let's say I have this pod and I have this application container. Now, if I put one more container inside of a pod, which is needed by the application, the actual application, then it would be called as a sidecar container. So what this sidecar container does, it helps the application itself in some way or the other. It can be any way, but if this container is helping the actual application, then it will be called a sidecar container. So where the term proxy comes from. So I hope you have heard about proxy in your organization. So when you try to connect to internet, let's say from a server, you cannot connect it directly. All your laptops or all your computers do not have direct connectivity to internet. You have to go to the internet options and set something called the proxy setting, wherein you provide the IP address of the proxy server. So that's what proxy does. Proxy is just a way wherein you are camouflaging the source of origin. So in this case, what will happen? Now, let's say this server wants to send traffic to internet. It will forward the traffic to the proxy server in between, and the proxy server will send it to internet. So what is the advantage? A lot of things have been offloaded to the proxy server. So a lot of internet communication and configuration, TLS, etc., has been offloaded to proxy server. The actual purpose of a proxy server is to facilitate some function or the other for a particular server or application in our case. Now, if you remember, we talked about something called application container and POS container. So what is this POS container? It provides a network namespace for the containers inside of a pod. So is that a proxy or a sidecar? Actually, it is both, if you ask me. But in case of Istio, it creates one more service mesh proxy or sidecar. And in this case, it is called Envoy proxy. Envoy proxy is an open source tool or open source proxy, if you will, created by a company named Lyft. Istio uses Envoy in a great deal. So the service mesh proxy or sidecar is completely implemented by Envoy proxy. So all traffic from application or from one application to another application will go via the service mesh proxy or sidecar, which in case of Istio is Envoy proxy. So if I go back to the previous diagram, which is this one, all of these blue, light blue or sky blue boxes are actually Envoy proxy. So it runs along with other containers in your pod, which we'll see anyway in future. Now, as I said, Envoy proxy is the way Istio implements its service mesh, and it's an open source software. The way it works is that you have this application container inside of a pod, and Istio injects this sidecar container, which is nothing but an Envoy proxy in each and every pod, which is controlled by Istio. Similarly, let's say there's one more application. That application would also have an additional Envoy proxy container in it, in the pod. And all the communication from one pod to another would be handled by Envoy proxy. Now, as you can see that a lot of configuration or service to service communication has been offloaded to the service mesh. So application is not doing the communication directly. It is talking to the Envoy proxy, which is helping it to communicate to other servers. And this is how Istio service mesh is implemented. When you install Istio, you'll see there will be a lot of YAML files. Not a few YAML files, which will use to install Istio. But you'll not see any deployments or services or anything as such. In those YAML files, you'll find something called custom resource definition. So what is this CRD or custom resource definition? So I just wanted to talk about it a little bit because you might come across this CRD or custom resource definition in other tools also. Now, you have seen a lot of Kubernetes objects like services, deployments, replica sets, pods, etc. So those are all objects, and we mention the type of the object in the kind keyword. After API version, we have kind, and we mention the type of object there. Using custom resource definition, you can create your own object, which does not fall in any of the Kubernetes category. You can mention your own kind. You can create your own Kubernetes object by mentioning a kind which you define. And the way it is done is called custom resource definition. Okay, so let's go to the demo part. We'll install Istio and we'll take a look around what things have been implemented as part of that installation.